Hello everybody, this is the lesson 5 of our Python course. Uh, there is a couple of weeks that we didn't provide you any lesson, but as we discussed before, the last 2 lessons were optional and I was really busy, so I couldn't give you more lessons at that time, and we decided to give you some lessons online afterwards. So this is the one of those lessons. These lessons will not be for 3 hours like the previous lessons, but it will cover, every lesson will cover one topic. So in this lesson, first we will discuss about the solutions on the exercise given in the lesson 4. I hope you have done that at home. I will give you the solution just today. And then we will have a recap over mutable and immutable objects. It will not be a new topics, but it will cover it will be a review of what you already know. And then we will talk about classes. You are familiar with instance and class variables. You are familiar with garbage collection, but we will learn more about them, about it. And also we'll talk about class destructor, function types in a class, and alternative constructors. And we will also talk about the best practices we can do while we are working with classes. In the next lessons, we will discuss about class inheritance, scopes, and the other things. I already prepared those slides, but I think it will be very boring or very difficult to follow if we cover all of them in one lesson. So I decided to divide divide them such that we'll have every topic in every lesson. Okay, let's get it started. First, we will discuss about the solutions and the exercise that I gave to you in the last lesson, I mean lesson 4. So today I will give you the solution for the first 2 exercise. I will not give you the solution for this exercise because you already have good samples on slides 28 and 13 of lesson 4. You need just to follow those examples and do it for in the arrays. So I will only talk about these, the first 2 exercises. The first exercise was this one. Given the following data, write a Python program to add 1 to all the numbers. So you can see here, we have a structure, and this structure, this data is like an array, and its elements are some sub-arrays. So, and every sub-array has a string and also an integer value. So here I ask you actually to give me at least 4 different ways to do this exercise. We wanted the input arrays is this one, and the expected result is this one. So we want to add the second items in the sub-arrays by 1. We want to increase them by 1. And here, this is a list. You are familiar with list. I want to solve this exercise with lambda function and list. Then I will give you 3 more ways. Here, I just created this at least with the same structure that you can see here. Then I'm using, you are familiar with map function. We know that map function has two arguments. The first argument is a function, and the second argument is an iterable. So the map function receives an iterable and applies that function on every element of that iterable. So here I have a lambda function. You're familiar with lambda function. They are some anonymous functions, short functions that you can use inside map function. You can also use other functions. It's not necessary to be a lambda function. It can be just a regular function. But it's usually used in this syntax. So this is a lambda function which receives an item, an argument, and it would be every item of this iterable, this list, and it will return a sub-array for that element, which is the first elements of that sub-array and the second element plus 1. So this map function will be applied on A on that list, and it will return a map object, and we will convert that to a list using this function, using this list function. And if we print that, we will see that this is the expected results. Okay, let's do this using list, but using comprehensions. We know that a list comprehension consists of an expression and a for clause and 0 or more for and if clauses. So we don't have those for and if clauses, but we at least have an expression and a for clause. What does it do? It will iterate over an iterable here, and it will unpack every item of A to name and age. Every item of A is a sub-array, as you can see here. And then the expression uses name and age to create a sub-array for every element, for every iteration of these four. And it will create a sub-array with name and age plus 1. And all of them together will be a new list. So if we print that again, we will have the same expected results. The third solution is by using ND array and lambda function. So you remember that we said that NumPy arrays are some structure or some arrays that every item of that array has the same type, unlike lists. On lists, we could have elements of different types. But in NumPy array, all the elements have the same data type. Okay, but we also said that we can define a data type, which is a data structure. So to have this data as a NumPy array, we can define a data type, which is a data structure. And it says that our data structure has two fields, name and age. And the first field has a value of a string with 20 characters. And the second field has an integer value of 8 bytes. And now I'm defining a NumPy array with this data type, with this data, as you can see here. If you cannot remember these things, you can go through the previous lesson and review what you have learned before. We have the same NumPy array, we have the same lambda function, map and list here. But since we want to output a NumPy array, we have to convert the list, the resulting list, to a NumPy array with this data type. And if I print that, I can see this is exactly similar to the expected result. It was not necessary for me to do this one if I only needed a list object here. This is just to show you that to convert a list to a NumPy array, you have to use this structure. Otherwise, it would be just a list. Okay, and the last solution that I gave you here is using comprehension on NumPy arrays or ND arrays. So this is similar. Okay, when I moved my mouse, you will see that pop up. So it's better not to use my mouse here. So as you can see, it is similar to what we have in comprehension for list. And just the only difference is that we are using a data type here to create a NumPy array. Again, if I only use this one for B, which is a NumPy array, it will return a list for me. And it's not a problem if you can work with list. It depends on your usage, if you need a list or NumPy. But this solution is I mean, you can use comprehensions on NumPy arrays as well. The second exercise, it says that assume that you have this data and you want to turn it to this list. So you can do this one using lists. And to do that, you can use a map function, a lambda function, similar to what you had for the first exercise. But since this one, in this data, we have all the elements of this data, this list or this array, are of the same type, we can have a NumPy array without the use of data structure. So I can just define a NumPy array with this list, and the data type would be an integer object. And I can just do this exercise by just this operation. We have learned about broadcasting and adding and doing mathematical operations between the scalars and arrays, or between arrays with different sizes in the last lesson. And you can see that in NumPy arrays, we can do mathematical operations very fast, very easy. But for list, you have to do it with use it with a method like this. You cannot do this one for list. That's why exactly, I mean, that's the reason that why we have NumPy arrays. So they help us with mathematical operations. You are familiar with mutable and immutable objects, but here I remember that we have a question from GU in the last lesson, and at that time I tried to explain, but I felt that it's getting more confusing for you, so I decided to prepare some slides to explain that. To explain the important concepts related to mutable and immutable objects again. And these slides actually are very important. And whenever you forget them, just come back to these two slides. I provided you with two slides here. Come back here and review the examples to remember what they are, because they are really can change your way of programming in the future when you are working with functions, when you are working with classes, modules, and the rest, and different scopes. Then you will see that they can have a much effect on your program logic. So here, I'm just creating, you are familiar with variables. When we were explaining what variables are, we said that they are just some identifiers. What does it mean? This means that they are just some names that they are referring to some objects. We said that everything in Python is an object, and with variables, we can refer to those objects. For example, we said that functions, classes, force, everything that we have in Python are some objects, and we can just do an assignment between a function and a variable to be able to refer to that function object. So, or any other objects that we have. And so to define a variable, we only need to do an assignment by an object. And so it's not similar to C++, C++ and Java or other similar languages that you have to define the data type of that, or some other things. Here, this is just an assignment. And even in some resources, when you are trying to learn Python or find the solution for your problem, you will see that some people are referring to variables in Python with the word names. They are saying that these are just some names, they are not variables. But we are going to call them variables in this course. But you should know that they are different from the variables that you have in other languages. So here I'm creating a variable, an immutable variable of type integer by this assignment. Here I'm creating a tuple, which is also an immutable object by this assignment. And here again, I'm creating a mutable, in this time, I'm creating a mutable object, which is a list. All of them are just referring to these objects. When I print that, I will have this one. When I print their IDs, I have this one. And I can change this variable. When I change mutable objects like this one, their IDs will be changed. What does it mean? Another object will be created. But when I change a list, the change will be done in place, and that object will be changed. A new object will not be created. So for example, here, when I print that, I have the change, but the ID of the integer variable has been changed. The ID of this one also has been changed. If you compare them, you see that their IDs are not the same, but the ID of the lists are the same because they are mutable objects. If I do reassignment with some objects, it's again doing defining a variable. It's again creating objects. Unlike C++, for example, if you, in one scope, if you define a variable, you cannot redefine that. In Java, I think it's also the same. But in Python, you can do that. You can redefine that variable with any data type, any object that you want. And from now on, they are anonymous. For example, I could assign num to a list now, and it would be another object. And now I'm assigning that to the same data type, but it's another object. It's like I'm doing the assignment. So the assignment here is like defining another object and referring to that object using that variable. So if I print that, I can see these are just some new data, and their IDs are different from the previous one, even for mutable objects, because I'm defining it new variables here, even if their name are the same, they are new variables. We also have learned that tuples does not support item assignments, so I cannot do this one. But we did an exercise that showed us that we can have a tuple whose elements can be a list, an element that has an item of type list, and we can change that item since it's a mutable object. And the tuple will be changed, and the tuple object will be changed, and the ID will remain the same as it was in the past. So for example here, this is a tuple. The first elements of the tuple is a list. And when I print that, I can see this one, and the ID of that is this one. I'm appending, I cannot do item assignments, but I can use the append method of the list, the first element, to add 4 to this list. And as you can see, the change has been done. But when I check their ID, the ID is the same because I didn't change the tuple directly. I change it using the mutable objects that it contains. We can define we said that we can define some variables using our assignment by an object, like this one. We have seen that. But we can define the variable also by assignment by a reference. What does it mean? I define these variables. Now I can define these 3 variables by assigning them to some existing variables. When I print them, they are referring to, at first I print these 2. And now when I print this one, they have the same values as these variables. And when I print their IDs also are the same. What does it mean? It means that those new variables are just some references to the same objects. So we said that variables are just some identifier, are just some names to call some objects. So now they are also referring to that. But okay, now I want to change them. What will happen if I change them? I change these variables. I could also change this one and to see the effect, but they are similar. From this moment onwards, these variables are equal to these variables. But depending if they are mutable or immutable objects, the change on each of them will be affected or not be affected by the other. It will be shown or not be shown by the other variable. For example, I'm changing these 3 variables. I print them. I can see the change. For the first 2 variables, since they are immutable objects, their ID has been changed. And for the third one, since it is a list, its ID didn't get changed. And now I print these 3 variables, and if I check that, I can see that the immutable objects are still referring to the previous values, and not to the changed variables, not to the changed objects, because they are immutable objects. But the list is showing the change, and the ID is the same because it's a mutable object and the change is done in place. So these are the important knowledge, the important pieces of knowledge that you need to know about mutable and immutable objects and variables. So So it's important to memorize all these things, and if do practice more and try to memorize them, and whenever you forgot them, you can just come back to these two slides to remember them again. Let's come back to classes. We have started to learn about classes in the last lessons, but we will have first a review of what we have learned in the previous lesson, and then we will come back, we will continue learning more about classes. So we said that a class is a user-defined prototype for an object that defines a set of attributes that characterize any objects of the class. And the attributes are data members. Data members are class variables and instance variables. And also the methods and, the attributes are data members and methods, and the data members are class variables and instance variables. And to access to them, we can use the dot notation. We explained that what is instantiation, the creation of an instance of a class. What is an instance? It's an individual object of a certain class. And for example, we have a class circle. We can have an object called obj. It can have any name. It's just a variable, which is an instance of our circle class. A method is a special kind of function that is defined in a class definition. A data member or an attribute, it can be also this one, is a class variable or instance variable that holds data associated with a class and its object. An instance variable is a variable that is defined inside a method and belongs only to the current instance of the class. So instance variables are related to the instance of the class, not to the classes. But class variables are some variables that are shared by all the instances of the classes of a class, and they belong to, in fact, they belong to the class. Class variables are defined within a class. I will, in the next slide, I guess, I will discuss about how we can define and call class variables and instance variables, and you will see the different ways that we can define them. You are already familiar with them. In the last lesson we discussed about them, but I wanted to have all the ways that we can define them together in one slide. So in the next slide you will see more about them. Class variables are not used as frequently as instance variables are. The main use case of class variables is defining global constants related to the class. For example, mean and max variables for instance variables, and commonly used values and constants such as pi. So if you want to have some constants inside your classes, then you can use class variables because they are shared with all your instances of the class. We said that the class syntax is like this. We have the first, the keyboard class and the name of the class, the optional documentation string, which explains how the class works and what's the usage of this class, and the class suite. I created a table here for you to explain how we can define and call instance variables and class variables. Instance variables are bound to an instance. We can access to them using self inside the class. We will discuss about self more. later. Class variables are shared among all the instances of a class. So how can we define instance variables? And you can see here, I make these two lines in green. I wrote these lines in green. The reason is that because these two ways are recommended for defining an instance variable and for defining class variables. But you need to know the other ways that you can define instance variables, because you or your colleagues or some codes that you are downloading from the internet may do these things, and you should know what they are doing. And you may also use them wrongly, and it will create some bugs and some unwanted behavior for your program. So you should know all. But I really recommend you not to use the other ways to create instance variables and class variables. Just stick with the first methods that I mentioned in this table for both of them. So the first way to create an instance variable is to define them inside instance methods. An instance method, we will see more about that later, is a method inside a function, inside a class whose first argument is a reference to the object, to the instance of the class calling that method. So it will have self as the first elements of, as the first arguments of the function. So it's an instance method, and it will be called using instances of the class. So we can define instance variable inside instance methods. How we write self dot the name of the instance variable equals to an object. The other way, which is not recommended, is to define instance variables outside the class. Using two ways, we can do it using two ways outside the class. The first one, which you are already familiar with the examples that I gave to you in the last lesson, is set attributes, the object name, the name of instance variable, and the value for that instance variable. The second way outside of class is to use the name of the instance, to name of the object, dot, and the name of the variable equals to object, the value that you want to assign to this instance variable. Remember this one because we will have another example that you will see that if you use this one, you may see some unwanted behavior. I mean, you didn't want to do this, but you may do it. Just keep this in your mind because you will see that in the examples. How we can define class variables. So the first one is to define to define the class variable in the body of the class. And we just write a name for the class variable equals to an object. The other ways, again, are not recommended, is to define the class variable inside the function using the name of the class. So we can define the class variable inside the functions of the class using the name of the class dot the name of the class variable equals to an object. Outside the class, we can use again the name of the class dot a name for our class variables and the object. These two are not recommended. How can we call instance variables and class variables? We can call them from inside the instance method using self dot the name of the instance variables, and we can call them from outside of a class in two ways. The first way is to use the name of the instance, the object of the class, dot the name of the instance variable. The second way is get using the function get attribute, the name of the instance of obj here is instance name. They both are the same. The name of the instance variable and a default value if it doesn't exist. How can we call class variables? Using the name of the class everywhere, either in the class or outside the class. Dot class variable, the name of the class variable. But outside the class, we have another way as well. Outside the class, we can either go for this way or this way, but inside the class, we only have this way to have access to that class variable. So outside the class, we have the other way, which is accessing to class variable using the instances of the class, instance name dot class variable. If the same attribute name occurs in both an instance and in a class, then attribute lookup prioritizes the instance. So you should not have an instance variable and a class variable inside the class with the same name. If you do that one, then the lookup, the attribute lookup will prioritize the instance. So it will always use the instance variable if you refer to that using the name of the instance. So don't do that. We usually use capital letters for class variables. All the letters of the class variable will be of capital letters, and for instance variables we use lower case letters. So here I'm creating this example. I'm trying to modify a class variable. So I create a class here which only has a class variable. And then I create two instances of this class. When I print the max speed from both of them, I can see it's 3 for both of them because we said that a class variable is shared among all the instances of that class. I do this one. I think with this one, I wanted to change to modify a class variable, but this is not correct. As I said, remember this one. We said that if we use instance name dot a name equals to an object, it will create an instance variables. It will not change the class variable. We can here, we said that we can access to class variable using the name of the instance. But if you set that to some value, then it will be like this usage and it will create an instance variable for you. So if you want to modify a class variable, you should go for this syntax. So again, for calling these instance variables, for calling class variables, I suggest you to go for this this way. Otherwise, you may have some difficulties. So here, when I do this one, an instance variable with this name will be created. So this object only this object, not P2, not the class, will have an instance variable with this one and also a class variable with this name. So we will have a class variable, an instance variable with the same name. When I print these two, I can see 7 and 3. The first one is the instance variable for P1, and the second one is a class variable for P2. I didn't do that, but if I just write here, delete this attribute, you remember from the last lesson, we had a delete attribute in Python, in the last lesson in Python that will delete an attribute of an object. If I write here, delete attribute P1 max speed, sorry. If I delete this one, then after that, if I print P1, that max speed, it would be the class variable. So it will just delete the instance variable. And after that, I can access to the class variable using the name of the instance. So if I want to access and edit max speed, I should use this syntax, which is the name of the class dot max speed equals to 7. So to modify class variables, go for the name of the class. And if I do this one for both of them, for both objects, this value has been changed, and I can see the change for both of them, from both of variables. We said that we can create a class variable outside the class definition, and it can be done using the name of the class dot max speed equals 10. So here I have just a class, an empty class. You are familiar with pass. We said that if we write pass, it can act like an empty suite. So we can define an empty class and add everything outside the class. But we don't like that. We just, I just want to show you how you can do that. But when you have any object, I mean, a side note is that if you have any object, I mean, we know that everything in Python is an object. So to see the built-in and built-in functions and all the other attributes and methods that you define yourselves from an object, you can just use this function dir using the name of that object, and by calling that over the name of the objects to see, you can, to see all the attributes and methods of an object. Either you define that or they are built-in functions. You can just call dir function over the name of that object. Then the whole things will be shown here. For example, here, I only created a class variable for this player and I didn't add anything to this class. When I use dir for that, you can see that there are many functions that are already defined for this class, and I can use them. For example, constructor, reaper, set attribute. You will see them later what they are, but I don't think so that I explained STR in the previous lesson, but I will discuss about them later on in the next lesson, not today. And some built-in class attributes are dict, doct, name, module, basis. So doc is just the documentation string, and if it's none, if it is not defined, name is the class name, module is the module name in which the class is defined, basis if you have inheritance, and it will give you a tuple containing the base classes. So you have many functions and attributes. If you do not define any, Python will define some for you if you use these keywords. How can we destroy objects? You're already familiar with garbage collection. I told you in Python, we have garbage collection. We have a garbage collector, which is responsible to delete the objects that we are not using anymore. And this helps us to not be worried about the memory much. We already are, we have to be worried about mutable and immutable object. We have to think about, take care of them. But for most of the cases, we don't need to, for example, it's not very similar to C++ or Java that you need to delete the pointers or the rest. Everything can be done with garbage collector, like what you have in C#. So garbage collection is the process of periodically reclaiming blocks of memory that no longer are in use. But how does it do? Python's garbage collector runs during program execution and is triggered when an object's reference count reaches 0. So for every object, we have a reference count. We know that how many objects are referring to that object. So for example, an object's reference count increases when it is assigned a new name. I said to you in the early slides that variables are just some names. So here when we say it is assigned a new name, it means that a new variable is referring to that object. And also it is placed in a container, list, tuple, or dictionary. So an object's reference count increases when these two happen. Only one of them will trigger this thing. The object's reference count decreases when it is deleted with del function. Its reference is reassigned. Its reference goes out of the scope. You are already familiar with the scopes. For example, when we're defining a function, I said to you that the variable that you define inside a function cannot be accessed from outside of the function because their scope is the function itself. So when we go outside of the scope of the function, we don't have any reference to those objects. So then the object's reference count will be decreased. For example, here I'm creating a reference to 40. An object will be created. With this one, I'm defining another reference to 40, and so the reference count of 40 will be increased. And with this one, I'm again I'm putting B inside the list. So again, a reference will be the reference count will increase. Here, if I delete A, the reference count of the object will decrease. With this one, since I'm defining another variable, B is not referring to 40 anymore. So the reference count of 40 will decrease by 1. And here again, since I'm changing the first elements of the list, the reference count of 40 will be decreased as well. So from now on, the garbage collector is responsible to delete 40 because the reference count of the object reaches 0. Okay, we have learned how garbage collector is working, and now I want to give you some explanation over class destructor. We know what is class constructor. It helps us to create an instance of the class. And what is class destructor? It helps us to delete the instance of the class and objects of the class. So it's the class destructor in Python is the function with this name, and it will be invoked when the instance is about to be destroyed. When it will be destroyed? When the garbage collector is going to delete that because its reference count reaches 0. It might be used to clean up any non-memory resources used by an instance. It's not necessary for you to write this one. It depends on your usage. You may, for example, open a file in constructor and you want to delete that and close that in the destructor. You can do that even in some rare use cases. It might be okay to do something like this, but it depends. So the destructor is for that. For example, here I have a class whose name is point. I have a constructor. Inside the constructor, I have 2 instance variables. I have a destructor like this, and its elements should be self. I mean, it should have a self as its elements, as its as its arguments. And I'm just showing the name of the class. I'm saying that this class is destroyed. It's just a message that I'm going to show in the destructor. Now I'm creating an object using the constructor of this class. The constructor will be called by this syntax, and then a reference to this object is inside a PT1. I'm also defining 2 other references to PT, to this object, this point object. So we have 3 different reference here. So the reference counts of that object is now 3. And when I print their IDs, all of them are referring to the same object. When I delete PT1, the reference count will be 2 now. And when I delete this one, it would be 1. When I delete this one, it will be 0. So now the reference count is 0, and the destructor of this point object will be called. And as you can see, the destructor is called only once, not 3 times because of every delete. So these deletes are only deleting the reference, one reference to that object, not the object itself. We have learned about destructors, instance variables, and class variables. Now we want to learn about function types in a class. We have 4 different function types in a class. So here I'm going to explain different function types using one example. We have a class here whose name is a square till here. This is the class definition. It has 2 class variables, then a constructor, 2 instance variables, which are defined in the constructors using self dot. And here I have a function, which is an instance method. It has self as its first argument and some other arguments. It can have access to class variables using the name of the class, to instance variable using self, and it can change all of them and print some results. So instance method can be accessed only through an instance of the class. Here I'm creating an object of this class, and I can call this instance method using the name of the instance. And if I do that, I can see these results, 5 and 5. It can be only accessed through an instance of the class because it needs self, and self is referring to the instance of the class that is calling this object. Sorry, this function. I have another function here. This function is just a function in the class. A function in the class, you can see that it doesn't have self, it doesn't have CLS, it doesn't have anything. It's just like a regular function that you define. Instead of defining it outside the class, you have defined that inside the class. And it is not common. This is a function in the class and can be accessed only through the class name. And it knows nothing about the instance variables. So as you can see, I can only access to the class variables, not instance variables. And it is obvious why, because I don't have self here. How can I access to instance variable when I don't have self? So now I only can access to class variables. The other function that I have here is a class method. The first arguments of this class method is CLS, which is a reference to a class, not an instance of the class. Class methods can be accessed through the class name and the instances, but it knows nothing about instance variables, again because it doesn't have self here. So it can only access to class variables. What is the static method? Static method is defined with this macro. For class method, you also need to write this decorator here, but it doesn't have self or CLS here. It can only access class variables, not instance variables. So it can be accessed through the class name and the instances, but it knows nothing about the instance variables. Let's see here. I created this one. I called instance method. I tried to call a function in the class using the name of the instance. It was not possible, but I can call class method and instance, a static method using the name of the instance. I cannot call instance method using the name of the class, but I can call the rest using the name of the class. So we had in total 4 different function types, and the most common ones are instance methods. And let's see what's the usage of class methods and static methods. We said that a function in the class is not really common. Also, static methods are not very common, but let's see the usage of static method and class methods. If you are already a programmer, you know that, for example, in C++ or other languages, we have we can define multiple constructors. We have copy constructors, we have a default constructor or other constructors. But in Python, we only have one constructor, which is defined using the method init with 2 underscores that you can see here, leading and trailing underscores. They are, the name should be always like this. But in other languages like Java and C++, the name of the constructor is the name of the class. But here, the name is this one. So we have a class here. It has a class variable. This is the constructor. The first element is self, name, salary, instance variable, and again here. So now I want to have an alternative constructor. Sometimes you want to, for example, here I can create an object of employee with name and salary in my hands. But sometimes I wrote the name or the salary inside a file, and I want to have a constructor that extracts that name from that file and creates an object from that class. To do this one, I have a class method which has CLS as the first element and the file name. It will be with open, and the first line is the name of that. It's just an example. It can be any other thing. But just imagine this is another constructor that I want to have. So with this one, I can call the constructor of this class using CLS and the parameters. This is a default value. I could write here also a value for salary, but I didn't call that, so it will use the default value for salary. So the CLS will call init. So this is the way that I can have alternative constructors in Python using class methods, because they have CLS, and CLS can call the constructor of the class. And here, if we know that class methods can be called using the name of the class. And now, if I do this one, an object of type employee will be created, and emp will refer to that. Another example. For example, here, I want to create an object of better date using a str object. So I created a class method from str, CLS, and date, and it will split the dates, and it will call the constructor using year, month, and day that has been extracted from year. And here it will call, the constructor, and an object will be created. And if I print the instance variables, I can see them here. So just remember, when I was talking about strings, I said that there are many different functions. When I was talking about the data types, I said that there are many different functions, useful functions that we can use them. And but we didn't have time. We cannot cover all the functions. But with these examples, you can see some usage of them. For example, here I'm using split. I already gave you some examples of them, but I want to recommend you to do more exercises and to keep this in your mind, that there are many useful built-in functions that you can use them. So you don't need to write a function here to do the split for you. You can just use the built-in function for str objects to do this process. And here I'm defining 3 different variables with 3 different object values. So the usage of the static methods. The static methods have limited use. They don't have access to the attributes of an instance of a class. So when they don't have access to the attributes of an instance of a class, they cannot be very useful. They also don't have CLS to be able to call the constructor. So what we can do with them, we also have these methods in other languages. They can be useful to group some utility function together with a class. For example, you have a you have a function that is only used for a class, but it doesn't work with the states of the class. It doesn't work with the instance variables. So, or instance methods. So then it's better to put them inside the class, but as a static function. So it will not change the state of the class, but it's a function that can be outside the class, but it's related to the class. So it helps the people who are using your using your class and that function to know that this function is related to this class. This function is for this class and it doesn't have any other usage. So it's better to be inside the this class. It's more related to its meaning, its usage. So for such functions, we put them inside the class, but they don't change the state of the class the state of the instances. What are the best practices that we can have in while we are working with classes? We said that, I guess I said that, I'm not sure, but if not, I'm saying that now. It's better for us to define our classes in a separate file. If you remember, for example, in C++, we define them in a header file. So here, and also a CPP file. Here we are saying that you should define your classes in a .py file. Its extension is .py, and use the import statement to import them. In C++, you use include that header file to be able to import that class, but here you use import function. So for example, you have a point class which is defined in point.py. It doesn't have any other executable code inside itself. It only has a class definition, and you can import that with the name of the file. And when you want to create an object of that class, you have to write the name of import here. You will see later in the next lessons what the other ways to import a module, and you will see that in some cases you don't need, but this is the best practice. It's better to call it like this. The other things that you should keep in your mind, that you should initialize instance variables in the constructor. So it is recommended to create instance variable in the constructor, although it is possible to create them inside the other instance methods of the class, or even outside the class. So as I said, I said that you should use, you should define that inside the instance methods, but I'm saying that now it's better to define that inside the constructor, not outside, not on the other instance variables. You can, if you do not know why, I give you 3 reasons here, but you can also do it yourself with some example to see how bad it is if you define some instance variable inside the instance methods, not in the constructor, and also outside the class. It will be really disorganized. So if you define that inside the constructor, it will be easier to know where all the attributes are, to know all the attributes. Attributes are created when the object is created. So if you define that, for example, inside another instance variable, those instance variable will not be created until you call that object, even if you until you call that instance method. So for example, you may create an object using the constructor. It has some instance variables, but since you have another instance variable that is defined inside another instance method. But since you didn't call that function, then your object will not have that instance variable, and it will bring us many ambiguity, many bugs for you. So it's not really good to do this like that. You can define some instance variables inside some instance method, but you have to call that. I mean, you don't have to, but it's better to, it's recommended to call that instance method inside your constructor. In this way, all the instance variable will be created inside your constructor. It's more organized, readable, and it will lead to a maintainable piece of code. The naming convention is to use Pascal case for classes and a snake case for functions and attributes. And also for class variables, it's better to use a snake case, but in a capital way. If you Google for them, you will see that Pascal case is a naming convention in which the first letter of every word is capital, and they are all the words are next to each other. But in a snake case, all the letters are lowercase, and the words are separated with underscore. But as I said, for class variables, use a snake case, but in all the letters should be capital. And keep self as self. I said that instance methods can, the first elements of, the first arguments of instance methods are a reference to the object that is calling that instance method. But it's usually a self, but it can have any other name. For example, here I wrote Kitty at here, and Kitty here is referring to the name of to the name of the instance that is called. But it's not really good to do that, because it will be very confusing. It can be confused with a function in the class, so people may not understand that this is an instance method. So don't do that. And self is commonly used for all the people that are working with classes in Python. Use docstring. You know, the documentation that you write for your classes is a message that can be shown when you call help function over your objects. This will help you, the people that are using your classes, to know how your class works and what's the usage of your class. So do that, and it will help the person using your class. Another topic that I'm going to talk about that is inheritance. We have many other topics left to discuss about that, and I will provide you with more lessons. Probably I can upload the next lesson in 1 week, I hope. But if you have any question, you can send me an email using this email address that exists here. I hope you learn a lot, and don't think that if you just listen to this course is enough. No, you have to practice, you have to do some exercises, and the more you work, the more you learn. So go ahead and learn more, and make me also motivated to learn more. Have a nice time, everybody.